Hi everybody. Today I'm going to show you some things about proofs. We're going to work through 5 proofs together. You're going to do a nice job. Make a nice clean copy of this. Make the same sketches for the same given, and we'll come to the same conclusions. You turn them in, you get a good grade for this. It'd be a nice thing to show you. By the way, hi Annalisa. Hope you're watching too. So we're going to start off with this thing that you probably know something about. I'm going to say if line L is parallel to line M, prove that angle 2 and angle 3, the same side interior angles, are supplementary. Let's walk through that proof right now and see how that would get done. There's a lot of similarities as you look at all these proofs. The first thing I would tell you is the first statement is the given will always be called just that, given. We're proving that if these lines are parallel, that angle 2 and angle 3 must be supplementary. Now that's something we've been talking about and writing equations with, but we've never proven it. I just talked about the fact that we would. Let's jump in and get going. Statement 2. We're going to use a postulate. And perhaps you remember when we talked about parallel lines that I said that corresponding angles, we can agree that corresponding angles are congruent by postulate. And that would make me think that angle 1 is congruent with angle 3. And the reason I think so, corresponding angles are congruent, and that's just by a postulate. A postulate is something we accepted without proof. We just said, yeah, these angles are going to be congruent if those lines are parallel, angle 3 and angle 1. I'm going to say that here, corresponding angles are congruent. Might abbreviate some things. Corresponding angles are congruent, and that's by postulate. We just accepted that without proof that corresponding angles would be congruent. But now, I think we can make some other things happen. Bear in mind, when I'm finished, I'll have a statement that says angle 2 and angle 3 are supplementary. Now, do we see some things in this picture that are supplementary as we work toward finding other angles that would be? And I hope that you look at this picture and say, yeah, angle 1 and angle 2 are supplementary. Let me make that step right away. I'm going to say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And you say, well, why do you think so? Why would that be true? And I'll say because a linear pair is always supplementary. Now, we might want to write more than that, but that means that to me. If it's a linear pair, then it would be supplementary. Angle 1 and angle 2 form a linear pair, so I know that they are supplementary. They must add up to 180 degrees. We're going to probably want to make a substitution here. Since these angles are congruent, let me take the time to take this step and say, therefore, the measure of angle 1 is equal to the measure of angle 3. If they're congruent, wouldn't they be equal in measure? And yeah, that's certainly true. But what do you call that when you're doing a proof? And we're going to call that the definition of congruence. Definition, congruence. If they're congruent, then they're equal in measure. That's what it means to be congruent. And now that I have this statement, I think I can rewrite statement number 3. I'm going to call it statement number 5, but it's going to be different. I'm going to rewrite statement number 3, and I think I could put something in the place of something else. In the place of angle 1, I want to put something that's equal to angle 1, and you recognize angle 3 is equal to angle 1. So let's rewrite statement 3, and it would then say the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. You might be saying, well, you got to have a good reason for why you did that. Every step you take on the left-hand column has to have a reason on the right-hand column why you think it's possibly true. And I would say, this is true because if two things are equal, I can use one in the place of another in an equation. That's a substitution. Let's just write substitution over there. I'm going to abbreviate a lot of things. I think I rewrote statement 3 with information from statement 4. So you could say 3, 4 there in case anybody wanted to figure out what you were thinking about. But now, bear in mind what we were trying to prove. We wanted to prove that angle 2 and angle 3 are supplementary. Here says angle 2 and angle 3 add up to 180. Would you conclude with me that they are in fact supplementary? That's how I think I can finish this proof right now. I'm going to say angle 2 and angle 3 are supplementary. You might be saying, well, why do you think so? Well, here, tell me they add up to 180. And that's what it means to be supplementary. So for my reasoning for this, I would say that's by the definition of supplementary angles. Yeah, angles are supplementary if and only if they add up to 180 degrees. These added up to 180 degrees, so they must have been supplementary. Now you go to that page that is available to you, and here's the next thing that we're going to prove. These are just little proofs that are very understandable. This proof says if two angles of one triangle are congruent to two angles of another, then the third pair of angles are congruent. The given would be that angle A is congruent to angle X. And likewise, angle B must be congruent to angle Y. That's what we're given. The first step in every proof we'll ever do will always be given. And then we're going to work through a series of logical steps, and we should arrive at angle C being congruent with angle Z. I bet you can think of lots of reasons that would have to be true. If these two angles are congruent to those two angles, wouldn't the third pair of angles have to be congruent? I'm sure it's true. Let's see if we can't establish that now. I'm going to use the triangle sum theorem. That'll get us started, I'm sure. I want to figure out a way to get angle C congruent with angle Z. And if I use the triangle sum theorem, you would have to agree that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Not only that, but I can apply the same circumstance here for the same reason. Let's make that statement as well. The measure of angle X plus the measure of angle Y plus the measure of angle Z also adds up to 180 degrees. I need a good reason for every step I take. What's the reason we think these angles add up to 180 degrees? We ought to call that the triangle sum theorem. Yeah, we know that both of these things add up to 180. Now, a couple ways we could go here, but here's a nice way to look at this. I want to end up talking about angle C, and I want to end up talking about angle Z. Look at this top equation. Could you solve that for the measure of angle C? I think you could. I'm going to say that the measure of angle C would equal 180 minus angle A and angle B. The measure of angle A plus the measure of angle B. And likewise, since I want to end up talking about angle Z, could we solve this for the measure of angle Z? That's what that should say right there, is the measure of angle Z. The measure of angle Z should equal 180 minus angle X and angle Y. The measure of angle X plus the measure of angle Y. And you got to say, well, you got a good reason for this? And all we did to get from this statement to this statement is we added a negative measure of angle B plus C to both sides, measured a negative measure of angle A and B to both sides, and I'm going to call that the additive property of equality, the addition property of equality. When you add or subtract the same thing to both sides of an equation, we're going to call that the additive or addition property of equality. Now, I want to make a substitution. Often you will make a substitution. But to make that substitution in the place for the measure of angle A and the measure of angle B, I need to get the fact that these angles are in fact equal in measure. They are equal in measure, I just need to make that statement. Looking at the given, let's agree that the measure of angle A is equal to the measure of angle X. And likewise, the measure of angle B is equal to the measure of angle Y. And you might say, well, what's your reason for that? Well, if they're congruent, shouldn't they be equal in measure? Again, that's the definition of congruence. We got to do enough proofs so you start seeing how they're alike and how they're different. That'll happen a lot, that definition of congruence. Now, I think I can write one of these statements again. I'm going to take the top statement right there. I want to write it again. I'm going to call it statement number 5. But I'm going to change it. I'm going to put some things in the place of the measure of angle A and in the place of the measure of angle B. But they've got to be equal to those two things. And you see I'm all set up to do just that. Let's rewrite that box statement right now. The measure of angle C is equal to 180 minus, and in the place of the measure of angle A, something equal to the measure of angle A, you'd have to agree that's the measure of angle X, plus And in the place of the measure of angle B, something equal to the measure of angle B, and that's the measure of angle Y. You might say, hey, mister, what have you just done? I got to have a good reason for what you've just done right there. And I just replaced elements of this equation with other things that are equal to those. And that's a substitution. I think I rewrote statement number 3 with information I used in statement number 4. And now, look what we got going. I think we're nearing fruition. Reminding you, I want to end up with angle C and angle Z being congruent. Look what I have. Angle C is 180 minus x plus y. And angle Z is equal to 180 minus x plus y. Wow, I got these two things equaling the same thing. Therefore, I think they must equal each other. I'll make that bold statement. The measure of angle C is equal to the measure of angle Z. And that's the transitive property of congruence. When two things equal the same thing, when angle C and angle Z both equal the same thing, then angle C and Z must equal each other. That is the transitive property of congruence, or transitive property of equality, excuse me. Transitive, I'll call it. Just about finished with this proof. By the way, what did you want me to prove? You want me to prove that C and Z are congruent? If they're equal in measure, would they have to be congruent? I say, yes, they would. Therefore, angle C is, in fact, congruent with angle Z. And that's a biconditional. If they're congruent, then they're equal in measure, and if they're equal in measure, by golly, they're going to be congruent. I'll just call that the definition of congruence again. And that's what another proof could look like. I want to show you another one. This is an interesting circumstance. This is something you've heard me talking about before, that the exterior angle of a triangle equals the sum of the remote interiors. That's what I'm about to prove right now. I'm going to prove it 2 different times. I'm just going to show you different ways that you could prove this thing. Most of these things can be proven in different ways. I just think it's an interesting idea to show you that. So here we're given triangle ABC with exterior angle 1. And we are to prove that angle 1 is equal to the remote interiors, that this angle is equal to those two angles added up. That's given. And now I've got to go through a series of logical steps to end up with angle 1 equaling these two angles. There's a couple of things that are going to add up to 180. Wouldn't these two angles add up to 180? And wouldn't these 3 angles add up to 180? I think I'm going to start down that path that way. Try to get some things that are equal to each other. I'll start with that linear pair. I'm going to say the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. You might say, well, why do you think so? I'll say, well, they do make a linear pair, and if they make a linear pair, then they must be supplementary. Every step you take has to have a good reason on the right as we do these 2-column proofs. And I'm going to say this one is, if it's a linear pair, then they must be supplementary. These angles form a linear pair, so by golly, they must be supplementary. So those add up to 180. Now, you got some other stuff that should add up to 180? And I said, well, the 3 angles of this triangle should. I'm going to call that angle 2, just so it'll be easy to talk about it. I'm going to say the measure of angle A plus the measure of angle B plus the measure of angle C, the measure of angle 2 adds up to 180 degrees. And why would you say that? Well, why would these 3 angles add up to 180? We ought to call that the triangle sum theorem. And that's what I will, triangle sum, S-U-M theorem. Now, I got a couple things equaling 180, don't I? And if 2 things equal the same thing, then they must equal each other. That's a nice way to solve this proof, I think. I'll just jump right to it. If this is equal to 180 and this is equal to 180, then those 2 things must equal each other. I'll go with the measure of angle 1 plus the measure of angle 2 must equal the measure of angle A plus the measure of angle B plus the measure of angle 2. And you say, well, how could you come to this conclusion? And I say, well, if 2 things equal the same thing, then they equal each other is the transitive property. So my reason for statement 4 is the transitive property. The transitive property of equality. Remember what we want to prove. I want to get angle 1 to be equal to angle A and angle B. What can I do to make this angle, 1, be equal to angle A plus angle B? You might be thinking, well, you got to get rid of that angle 2 that's on both sides, couldn't you? And yes, that's what I want to do. I'm going to add a negative measure of angle 2 to both sides of this equation. I'll call that statement 5. And if actually I'm subtracting it, aren't I? If I subtract the measure of angle 2 from the left, I'm just left with the measure of angle 1. And if I subtract the measure of angle 2 from the right, then I have the measure of angle A plus the measure of angle B. And some people might call that the subtraction property of equality, but I'm going to call it the additive property of equality. I think I added a negative, what did I add to both sides? I added a negative measure of angle 2 to both sides, leaving me with just angle 1 on this side and A plus B on the other. I'm going to call that the additive property of equality for my statement 5. The addition property of equality. Now, hey, I'm finished, aren't I? That's all I needed to prove, that the measure of angle 1 is equal to the measure of angle A plus B. That's what I've arrived at. So I'm done with that. I would like to show you a different way of doing that proof. Just because there are so many different ways, all of these things could be done. And I don't want to act like there's just one way it could have happened. So just walking through here, let's take another look at this one. You have to make the same sketch and give me the same given. We're going to come to that same conclusion, but in a very different way. Okay, so I'm given triangle ABC with exterior angle BCD. There's my exterior angle BCD. And I am to prove that this exterior angle BCD is equal to the sum of these two remote interiors. Here's the given. Just that we have this triangle with an exterior angle. We're going to do this differently. I'm going to use the parallel postulate. You've heard me talk about the parallel postulate. Through C, show CD parallel to AB. I think I can do that. I'll have to make a statement about it. I'll say, show CD, that ray, parallel to AB, that line. And you might say, well, what makes you think you can go around through this point, not on that line, showing a parallel? I say that's the parallel postulate. It is quite the useful postulate when you're doing plane geometry. Now I'm going to want to talk about these couple of angles. Let me call an angle 1 here and an angle 2 there. And let me show that these lines are parallel by putting an arrowhead on these couple of parallel things, these parallel lines. And I'm looking for angle pairs that should be congruent. What about angle A? You congruent to somebody? And I think, yeah, it must be. Angle A is congruent with angle 2. What makes you so all fire sure that angle A is congruent to angle 2, you might ask? And I say, well, if these lines are parallel, then those are corresponding angles. And if lines are, let me say this for statement 3, if lines are parallel, then we have congruent corresponding angles. C-O-R-R-E-S, corresponding angles. So I know that angle A is the same as angle 2. What about angle B? Is it congruent with somebody? And I say, yeah, it is, as a matter of fact. This angle at B, it's congruent to this angle at 1. When you think about these parallel lines cut by this transversal, angle 1 and angle B are alternate interior angles. I'm going to make that note, that angle B is necessarily congruent. If these lines are parallel, then angle B is necessarily congruent with angle 1. And that's because if lines are parallel, then we have congruent alternate interior angles. Congruent alternate interior angles. Now, what can we do with this? Bearing in mind what we want to end up with is angle BCD, this angle out here, is equal to angle A plus angle B. I'm going to make an angle addition statement. Check this out. Isn't it true that the measure of angle BCD is equal to the measure of angle 1 plus the measure of angle 2? Just looking at this picture, stuff we did at the beginning of the year, isn't it true that these two angles add up to angle BCD? We'll just call that statement 5, angle addition. So now that I have this statement, I think I can make a substitution there. And bearing in mind what I want to end up with is BCD is equal to A plus B. That this exterior angle is equal to those two guys added up. I want to make substitutions here, but I need to take a second and go from this congruence to equality. Just a little step. Call this in statement 6. I think that the measure of angle A equals the measure of angle 2. And, likewise, the measure of angle B is equal to the measure of angle 1. If they're congruent, mustn't they be equal in measure? After all, that's what it means to be congruent. So what's your reason over here? Definition of congruence. Definition of congruence. If they're congruent, by golly, they're equal in measure. And if they're equal in measure, then we can make a substitution. Let's rewrite statement 5. I'm going to write this guy again. Put some things in place of other things because we know them to be equal. And that would say that the measure of angle BCD is equal. Hey, mister, what can you put in the place of the measure of angle 1? There's got to be equal to the measure of angle 1. You'd say the measure of angle B, huh? And what could you put in the place of the measure of angle 2 that you know to be equal to the measure of angle 2? That'd be the measure of angle A. And what we've just done is a substitution. I think I just rewrote statement 5 with information from statement 6. So I'm going to go parentheses 5, comma 6 right there. And this is not exactly what we wanted to end up with, but it's pretty darn close, huh? And the commutative property, I won't fret about it. The commutative property says I can switch that order. So we do see that BCD is equal to angle A plus angle B. And this is perfectly fine with me. I've got one more I want you to look at with me. And this one's a little more interesting. This is the 5th one on that page. And this is a very useful one. If two angles are congruent, and those two angles are also supplementary, mustn't they be right angles? I'm going to use this sketch and say that angle 1 and angle 2 are congruent, and they're supplementary. That will be what we'll call our given. We're going to work through a series of logical steps. Each one we can verify and talk about the property that we're using, and we should end up with angle 1 being a right angle. Let's start down that path and see what we can do. Lots of times people have a hard time getting started with a proof, and they say, I don't like proofs, I don't know how to get started. I would always tell them, investigate the given. So what, these angles are supplementary? What does that mean to you? And I hope right away you say, well, that means the measure of angle 1 plus the measure of angle 2 adds up to 180 degrees. If they're supplementary, don't they have to add up to 180? Isn't that what that means? So what should I say on the right-hand side? Rather than write, isn't that what it means to be supplementary? We'll write definition supplementary angles. Yeah, if angles are supplementary, then they must add up to 180. But now, since these angles are congruent, I think I'd like to make a substitution here. Substitutions happen a lot as we start these ideas of proofs. Statement 3, but before I can make that substitution, I have to say that these angles, since they're congruent, they're equal in measure. The measure of angle 1 is therefore equal to the measure of angle 2. You say, just because they're congruent, you think they're equal in measure. And I'll say, yes, I do. What's your rationale, mister? I'll say, well, that's the definition of congruence. If angles are congruent, then they're equal in measure. Definition of congruence. That's what it means to be congruent angles. Now, could you rewrite statement 2 using information from statement 3? I believe you could. Let's see what happens when we do. I want to keep angle 1. So let me just keep angle 1 from here, because I want to end up talking about angle 1. The measure of angle 1 plus, hey, what can you put in the place of the measure of angle 2? But it must be equal to the measure of angle 2. Also, the measure of angle 1 adds up to 180 degrees. I think I just rewrote statement number 2. But I did put stuff in the place of other stuff just because they're equal. And we're going to call that a substitution every time we do that. I think I just made a substitution. I rewrote statement 2 with information from statement 3. But now, bearing in mind what we want to prove, we want to say angle 1 is a right angle. But what we see is 2 measures of angle 1 is equal to 180. What if we took a half of both sides of this equation? Take a half of the left and a half of the right. A half of the left-hand side would just be the measure of angle 1. And to take a half of the right-hand side, it would be 90. Is it okay to take a half of both sides of an equation? I say, yes, you could. You multiply both sides by 1/2. I'd call that the multiplicative property of equality, or the multiplication property of equality. Some people might call it the division property. I think we're going to multiply both sides by 1/2. Multiply both sides of this equation by 1/2, and we'll have the measure of angle 1 is equal to 90. I'm going to call that the multiplicative property of equality. But I'll abbreviate it. Multiplication property of equality. We're getting pretty close to finishing this up, huh? What I'm supposed to prove is angle 1's a right angle. And if the measure of angle 1 is 90 degrees, must it be a right angle? Yeah, it's got to be, huh? So I'll conclude that now.